Hello my dear friends and students. Starting from first session of this series of video tutorial on molecular docking, so far we have successfully completed the docking of our ligand against the target protein. In this tutorial, I shall show you how to read, visualize and interpret the result of docking using the DLG file. Here we will read these results in 3 steps. In this first step, the reading of the docking log file will be explained. The second step is about the visualization of several ligand poses inside the grid area of protein ligand complex. Here you will learn how to save different poses of the ligand inside the grid area of receptor protein. Reading the DLG file for the results. Open your working folder. This is the DLG file. The DLG file can be opened with text editor or notepad and check for results. I am going to select this notepad and click OK. Scroll down this file and here you will see final genetic algorithm docked state. Starting from here, these are the docking result of each run. Likewise, here is the state of first run. For this first run, here is the estimated free energy of binding minus 10.53 kilocalories. The inhibition constant 19.25 nm nanomolar at a temperature of 298.15 Kelvin. Down here you can see in this run there were 5 active torsions. Moreover, the XYZ coordinates of each atom, likewise these are given here. From here started run 2. Details of this run 2, energies and related informations. You can also search for histogram. These are information and this is the histogram. The number of distinct conformational clusters found here is 1 out of 10 runs. The lowest binding energy here is minus 10.61. Down here is RMSD table. Down here you will find the different clusters with rank and energies. Rank 1 from here, run number 1, 2, 3, 4, 5 and so on up till 10. The binding energy, so the lowest energy is recorded for run 4. Cluster RMSD and reference RMSD. These are the energies of different poses during this docking interaction. So remember that the lowest energy pose was achieved during run 4 with minus 10.61 kilocalories per mole. Visualizing the binding interactions. I am going to delete the docked molecule from here. Go and delete all molecules. For visualizing the result of this docking, go to Analyze, Docking and press Open. Select this docking parameter file. You can see here, read 10 dock confirmation from DPDLG. This shows that this file has information on 10 poses of the docked ligand. To visualize protein structure, again go to Analyze, Macromolecule and then press Open. If you have your docked protein inside the working folder, you will be able to see the protein ligand complex and this 3D viewer, and this protein molecule will be loaded automatically. Now this is the final confirmation of your docked structure. This structure contains the ligand as well as your protein. All the information related to the different poses are available inside this structure. In order to see various conformation of the docked complex, go to Analyze again. Down here, select Conformation and press Play. Using the buttons in this panel, you can display the 10 poses of the complex and select the best pose with the lowest energy and save it. Let me focus on the ligand in this complex. Here is the ligand. You can see here that this is our ligand. For better visualization of this ligand, you can click here in this circle. Now you can see the ligand very clearly. To see the different poses of this ligand, click here. You can observe the slight change in the ligand orientation. The third orientation, fourth, fifth, sixth, seventh, eighth, 9 and 10. You can press this play button and see how the ligand is moving inside this pocket. Let me press it again. To write a complex, click on this dollar symbol. This will open set play option. Drag this set play option down here so that you can see the different poses of the ligand. You can see here that there are many options: show information, build hydrogen bonds, color, show conformation list. Important are build the complex, the current pose, and write all, write complex, close this set play option, build all. So you can use these options for different purposes. By pressing this write all, this will save all the 10 poses and PDBQT format in the working folder. As I have pressed this button, let me show you these poses. Here are the 10 poses: configuration 0, 1, 2, 3, 4, 5, 7 and up to 9. All these are in totally 10 poses. You can also save this current pose 10 by pressing write current. As in this demo, the fourth pose was the most stable pose, so I am going to save fourth pose. Give it a suitable name. Like pose 4 with extension PDBQT and press save. Go and check in your working folder. Here you will see that pose 4 has been saved here in PDBQT format. You can also save a particular pose by pressing write complex and giving a suitable name here and pressing the save button. To display the energies of different poses in the set play option, click on this show information. You can see here that energy informations are displayed in this panel. Binding energies, ligand efficiency, inhibition constant unit, intermolecular energies, and so on. You can check from here that as soon as you change the pose of the complex, you can see that these energies changes. For pose number 3, for pose number 2, for pose number 1, and so on. As our fourth conformation was the most stable, you can see that the energies here are minus 10.61. The number of hydrogen bond interaction in each cluster can be displayed by clicking here in this box. You can see hydrogen bond information are displayed here. In complex 10, you can see that there is one atom in hydrogen bond. The amino acid from the receptor side is lysine 33, and the atom from the ligand is HZ1. Now let's go and see the hydrogen bond information in pose 9. In pose 9, one hydrogen between lysine 33 and HZ1. Pose 8, pose 7, 6, 5. You can see that pose 4 was the most stable one. Here you can see that there are two hydrogen bonds in this pose. The one is between the glycine 30 and HN. The second hydrogen bond is between lysine 33 of chain A. This is information about the chain of chain A and ligand atom HZ1. Now let's check the last three poses as well. Pose 3, one hydrogen bond. Pose 2, one hydrogen bond. And pose 1, one hydrogen bond. I am going to close all these panels. In AutoDock tool, you can also view the amino acid residues of the active site. To do this, go to Analyze, then Docking. In the docking option, click on Show Interaction. Here you can see all the information of protein ligand interaction. And this third pose, the ligand have interaction with at 3 position. You can see here the amino acids that are involved in ligand and protein interaction. Here ASP90, ARG83, valine 113, ASN111, ASP108, threonine 106. You can see those amino acids behind our site. The background color can be set by clicking in this box. You can select one from these colors. Suppose I am going to click here. You can see the background color change. You can select one of your choice. As I am not going to change the default color, so I am happy with white color. From this menu, you can change the display into solid instead of wires, but I am happy with wireframe. You can hide and display the hydrogen bonds by ticking here, hydrogen bonds. You can see the amino acid involved in hydrogen bonding are now displayed. Let me hide these. The image of this active side amino acid can be saved by clicking this button, Save Image. Here you can see Save Image panel is opened. You can give a suitable name. Likewise, I am giving it the name of image with extension PNG. Select the folder where you want to save this image. Push this change button. This is our default folder, so I am satisfied with this default folder to save this image there. Now press OK and check the default folder for this image. This is our default folder. You can see the image is present in this folder. You can watch this image. This is the image. I am going to close this panel. Here I am going to remind you a very important point. In the AutoDock folder, you can see the numbering of these saved poses. And these poses, the DP conformation 0 mean conformation 1 or pose 1. Conf 1 mean pose 2. 2 mean 3 and so on. So conformation 9 mean pose number 10. So you can visualize all these poses by opening these structure, these formats in Discovery Studio. With this, we have finished the series of molecular docking. Thanks for watching and hope to meet you in my new video tutorial. Bye for now.